Now that we understand our general flow, let's go back over to our users test.js file, and we're going to make sure that we write out all these steps right here before we start to run any tests inside that file. So we're going to write out a lot of code inside that file, and then eventually we're going to extract that and make use of it inside of our other two test files as well. Okay, so back inside my editor, I'm going to find the before all statement. So that's where we're going to do all this setup. I'm going to put in a couple of comments inside of here just to guide myself. And just so you know, we're going to do some of the steps, so we're going to write out some of the code in a slightly different order than the order that I showed you on the diagram back over here. So this order of steps, slightly different order, but at the end of the day, everything is just about identical. Okay, so we're going to first begin by randomly generating a role name to connect to PG as. That's going to be essentially our randomly generated username or role name that we're going to use to connect to our database. We're then going to connect to PG as usual. So in other words, using these existing credentials that we already have down here. We're then going to create a new role using the role name we generated up here. We'll then create a schema with the same name. After we've created the schema, we're then going to disconnect entirely from Postgres. And then one more step inside of here that I didn't show back inside the diagram, but as soon as I mention it, I think it'll make a lot of sense. We have to actually run our migrations inside of that schema. So whenever we create a schema, it starts off totally empty, no tables inside of it whatsoever. The tests inside this file and other files that we eventually put together are going to expect that things like our users table actually exists. So we need to make sure that all those schema migrations we had put together actually get executed. As a quick side note, the term schema migration and the kind of schema thing that we're working with right here, these are two very different kinds of schemas. They just happen to use the same name. So we're going to run our migrations in the new schema. And then finally, we're going to connect to PG as the newly created role. And because we are connecting under that role that has a name identical to the schema we had created earlier, all the following queries that we execute inside this test file, so any query that refers to any table whatsoever, they're always going to be kind of redirected to that newly created schema. Okay, so that's the general idea. Now before we write out any code inside the before all, we're going to add in a couple of import statements at the very top. So I'm going to import a function called random bytes from crypto. I'm going to get default as migrate from node pg migrate. So that's the library that we're using to actually run our migrations. And then we're also going to get something called format from pg format. The random bytes function we're using to randomly generate a series of numbers and letters. So this is essentially going to be used to generate our role name. So let's get started with the random bytes function right away. So I'm going to make a new variable called role name. That will be random bytes. We'll pass in 4 and then do a toString of hex. So again, just giving us back a random string of numbers and letters. There's one little side note around this. Whenever we create a role inside of Postgres, it must always have a name associated with it that starts with a letter. You can't have a role name that starts with a number. This random bytes function is going to generate a random string of numbers and letters. And so there is a chance that it's generating a string that starts with a number. And that would lead to an error inside of Postgres when we try to create a role using this role name. So to make sure that this string always starts off with a letter, we're just going to do something really simple here. We're just going to say take the letter A and then join on that random string right after it. So that's going to make sure that we always start off with a letter at the very start of our role name. Okay, so then after that, we're going to connect to Postgres as usual. That's going to be essentially the exact same thing we have down here. So I'm going to cut that and delete the return statement. I'll then paste that right underneath the comment. We'll make sure we put the await on there. And because we are now making use of the await keyword, I'll make sure that I mark the enclosing function as async. Next up, we're going to create our role. To create a role, we just run a very simple query. So we're going to do an await bool.query. And we will run create role. We're going to put in our role name with login password, role name. And around this second role name right here, I'm going to make sure that on the left-hand side and the right-hand side of that interpolation, I put in a set of single quotes. Very important to make sure you get those in there. So this is how we create a new role that we can use to connect to our database. Pretty simple and straightforward. Very similar to how we have a role such as whatever you have right here that you use to connect to the database as well. That's going to make a role with the given role name, and we can connect using that password. After that, we'll then create our schema. So we'll do an await bool.query, create schema, we'll put in role name, and we're going to also add in authorization with role name as well. That just makes it very clear that this role that we just created can access this schema that we're making. So in other words, make a schema, and we want this role that we just made to have access to it. Do double check and make sure you've got the spelling of authorization correct right there. As a quick side note, you'll notice that I'm doing some direct string interpolation for a query that we're about to send off to our database. And I told you earlier when we were talking about SQL injection exploits that we never want to have something that looks like this right here. In this case, we are running tests, so we're not working with any user-supplied data. So technically, no risk of SQL injection here. However, nonetheless, we will come back to this code in just a little bit and refactor it so we don't have this kind of string interpolation stuff, which can be very easily confused with having a weakness for SQL injection. So if you're worried about that exploit, we'll come back and fix this up in just a moment. Okay, so next up, we're going to disconnect entirely from Postgres. So that's going to be await pool.close. Remember, when we put our pool class together, we gave it a close method that we can use to disconnect from Postgres. Next up, we're going to make sure we run our migrations in that schema. And we're going to do so using this migrate function. So we're still using the same node pg migrate module to run our migrations. At this point, we have only used that module from the command line. So this time around, we're going to run our migrations programmatically. So we run them programmatically by using this migrate function. So we'll do an await migrate. We're going to have to pass in a couple of different options. First, we're going to designate the schema that the migrations are going to be executed in. The name of our schema is role name. We're going to designate which direction we want to run our migrations. So remember, our migrations can be used to advance forward the design and structure of our database or roll it back. In this case, we want to advance forward. We want to apply all of our migrations. So we're going to go in the direction of up. We're going to put in log and provide it an empty function. Normally, whenever we run migrations, this migrate function generates a ton of log statements and dumps them out at the terminal. Because we are running tests here, we don't really care about any of these log statements. And if we printed out all these logs, it would make it really hard to interpret our test results. So we're just going to say don't do any logging whatsoever. By providing this empty function, the migrate library is going to try to call that function with all the log statements that are generated. So we're essentially saying just take this empty function, provide all the logs to it, but we're not going to actually do anything with them. Next up, we're going to provide a no lock of true. By default, we are supposed to only be running one set of migrations at a time. But because we are trying to run multiple different test files in parallel here, we might be in a scenario where we are trying to run multiple different migrations simultaneously. Usually that would result in an error. So we're going to override that behavior by providing no lock true, which essentially means don't lock up the database when we are running these migrations. Next up, we'll provide dir, short for directory. This is going to be the folder inside of our project where all the migration files are stored. Our migration files are stored inside the migrations directory. We'll put in simply migrations like so. And then finally, we're going to specify how to connect to our database to actually run the migrations. So we're going to provide a database URL. We can provide some connection settings either as a string or an object. We're going to do an object. So inside of here, we're going to use the same exact host, port, and database from our earlier connect statement. But our user and password are going to be different because we're going to run these migrations under this newly created role that we made just a moment ago. So we're going to put into this database URL the host, port, and database. make sure on URL right there you have capital U, lowercase r, and L. And it'll provide the user as role name, and the password for that is role name. Then finally, after running our migrations, we're going to actually connect back to Postgres as the newly created role. We'll do another await pool.connect. We will provide once again the same exact host, port, and database. And then our user will be role name, and our password will be role name. And that should be it. Okay, very long video here. I apologize for that. But let's run our tests very quickly, and we're going to really just hope that our user's test.js file tests or passes all of its tests. But we still might have some failures inside of our other two test files. That's because they're still trying to contend over the user's table inside of our public schema. But the user's test.js file should be creating its own private schema now and running all the tests using that schema. So I'm going to make sure I save this file. I'll go back over to my terminal and do an npm run test. All right, so we might get 2 failures. Yep, looks like I got 2 here, but I should have at least 1 passing. And the passing test should be the user's test.js file. And it looks like it is. Well, I'd say this looks pretty good. Now that we've got some kind of early confirmation that this approach is going to work as expected, let's take a pause right here. We're then going to start to extract all this logic and make use of it inside of our other test files as well.